Hello everyone. In this video, I'm going to take you through a tutorial that we started in the first video, introductory tutorial on how to go about creating circuit programming in C. And we know that circuit programming is basically network programming. So in this video, we are going to start coding our first client-server programs. But first, we are going to first of all start with the server in this video, and then in the next video, we are going to create the client that's going to interact with this particular server. And for the purpose of this tutorial, I've created a file. I have named it helloserver.c, and these are the header files that are required to create both our client and server program in socket programming in C. So I have created this file. I've already defined function main, and now we are going to start coding this thing from scratch and see how we will be able to achieve a simple server in C that will just send a message, hello world, to any client that connect to it. So let's get started. So what I'm going to do, as we can see in this particular function main, the parameters that we define in function main, int argc and argv, an array by name argv. Now this will define, they are just parameters to take care of the argument that the user is going to pass over the terminal. So the first one, argc, is stand for the number of the argument, the parameter that will hold the number of the argument that the user pass over the terminal. While to be able to access the argument, we make use of this particular array argv, and which is a character array argv. All right, so let's see how. Now the first thing that we need to do, we need to make sure that the user, when the user is running this program, to run this program, all that the user need to do, let me make a comment here. So to run this program, to run the server, to run the server, to run the server. Now it run the server, issue the command, issue the command. So it's going to just backward slash hello server.c. So hello server, since we are when the user is going to run it, that means it has already been converted into an executable. It has been compiled, so it's going to run the server as such. Dot forward slash, is it forward slash? This is forward slash, yeah. So hello server, and then followed by the port number that the server is going to run on. Let's say 5667. So hello server 5667. So these are the two arguments that the user need to pass while running this particular server. And so these parameters int argc and argv, they are there to take care of this particular argument that the user is going to pass when it's running this our server program. So we want to make sure that the user actually run the server by executing this command, and to do so we need to perform a little check using our if. So I want to say if argc, as I've said earlier, argc is an parameter that will take care of the number of the argument passed over the terminal. So as you can see, we'll be able to access the number of argument that the user passed over the terminal using argc. So we want to check that the user actually enters 2 arguments. So I'm going to say if argc not equals to 2. Then if this is not equals to 2, then that means there is a problem. So we want to put the user on the right track. So I'll simply print out something directing the user that he has not run the program properly. This is the way to go about doing just that. So I'm going to say to run the server, just I have commented there, to run the server, okay, yeah, to run the server, issue the command dash hello server, followed by port number. To run the server, followed by port number. Okay, but to do it more something in a more better way, let me do it this way. To run the server, so I'm going to say name of the file, followed by the first argument is this, okay, and then port. Okay, sorry, this is how to go about it. I want to say the name of the file, port, sorry. So go about it, he's going to enter a string, and that string is the name of the file, and that name of the file is accessible via this particular is an array element 0, which is index 0, which means the first element in this particular array, and which is this particular parameter hello server. So argv0 refers to this first parameter that the user pass over the terminal while running this program, and we are accessing it using this particular argv array. So you can see argv is 0 means the first index 0 means the first element. That means the first element of this array is this particular first argument that the user pass over the terminal. So argv 0 followed by 4. So this conversion specifier for string will be replaced by whatsoever the value of this, and then it's going to print it, and then this port we just print it as a string as it is, and then we want the program to exit so that the user will have to start afresh. So as usual, after any closing brace, I usually make a comment to know what that closing brace is, what particular structure. So I'm just copy this, and I'll paste it here, and I'll save. Now next, in the first video, as you can remember, we say that to get our server socket programming server up and running, the first thing that we need to do is to create a socket. So first of all, we are going to create a socket. So I'm going to make a comment here. Create a socket. So now we are going to create a socket. Now to create a socket, we need a variable to hold the value of the socket that is going to be created. So I'm going to define it as int server socket socket file descriptor. As I've said earlier in the first video, as you can remember, we say that a socket is created just similar to a file descriptor. So with an ID, an integer ID, an ID which is of integer data type that will present that particular socket in the computer memory. So that is what we refer to as file descriptor. Just as when you create a file, a unique ID is attached to it, which we refer to as the file descriptor. So also sockets are treated just like files in C programming. So that is why we created a variable rather, name server socket fd file descriptor and of integer data type. Now the next thing, I'm going to invoke the socket function. So socket, and then put a statement terminator, and the first argument, as if you can remember, if you watch the first video, the first argument is the domain. So the domain, I'm going to make use of I'm going to substitute it with the value here, ifinet. So we usually make use of this value for the domain ifinet to represent IP version 4. So IP version 4 ifinet protocol family, address family rather, so is IP version 4. So we make use of this ifinet. Now the next thing is the type, whether it is a type of the socket that we wish to create. If it is TCP socket or AUDP socket. So we want to create a TCP server. So therefore we are going to specify it as TCP type of socket. So I'm going to say sock stream, and then here with just protocol IP, we make use of 0. So we have created our socket. So we have successfully created our socket. Now the next thing after the creation of a socket is to bind the socket to a port number and an IP address. So I'm going to comment bind the socket. So bind the socket. Now to bind the socket, we need an address that we are going to bind the socket to. And to make use of this address, to get the address, we need a structure which is situated within one of these header files, and that structure is called sock_addrin. So I'm going to create an instance of that particular structure. So like this, I'm going to say struct sock_addrin, and I'm going to call that particular instance of that particular structure as server address. Sorry, not here. Server address. So I'm going to comment here, create a sock addr in instance. All right, so now I've created a structure. So that now after creating the structure, now and when we fill the members of this particular structure, that is when we that is the members of this particular structure what we can use to associate our server with the IP address and the port number and the protocol family. So but before we proceed to that, we need to make sure that this structure is clean of any remnant data, that it doesn't contain any garbage data. Maybe it has previously been used recently, so it might contain some data. So we need to find a particular function called memset. So I'm going to invoke this particular memset, a function called memset, and I'm going to pass to it the address of this particular structure that I have created. So server addr, server address that I have created, and I'm going to pass this 0, which means I want everything to be initialized to 0 within this particular structure, so that any data that is there is going to be wiped clean. Everything should be initialized to 0. So and then the next thing, I'm going to pass the size of this particular structure, and then I'll say size of server address. So this particular functionality will wipe the server address clean, so that it won't contain any garbage data, any remnant data, and then make our program to have issues when we are about running it. Now the next thing, now we are going to fill the members of that socket with our with the type of port number and the IP address that we want, so that we can bind it to our socket. So we are going to say, I'm going to proceed this way to do so. I'm going to say server address dot scene family. Now scene family is one of the members of this particular structure that we created, server address structure. Okay, am I doing the right thing? No. What is this? I'm going to move away this server address.scene family. I'm going to refer to it as IFINet, which means IP version 4. Now the next thing, I'm going to see server address dot scene underscore addr dot s underscore addr. Now this will be used to fill the IP address. Since this is a server, and the server is free to use any IP address, is the host machine that the server is running on can be having many interfaces. Maybe it's going to be run over a local area network or a wide area network. It depends on how the user of the server is going to run it. So we want to be flexible here. We want to specify that the server can just have any address instead of restricting it to a particular address. So we want to specify that this particular server can have any IP address. And to go about doing just that, I'm going to say htons. Okay, HTONL. This HTONL is a function that is used to convert host to network and long integer data type, convert it from host byte order to network byte order. So please, if you need information more, that is what we call the endians, big endians and little endians. Please, you can just perform a little Google search to brief yourself about this, what you call host network order, host byte order, and network byte order. So I'm just make use of that particular something here. So here, this host and HTONL is a function that will convert from host byte order to network byte order, and any data that is of long integer data type. So, and we are going to pass to it in addr any. This will make sure this is to make sure that this application is flexible enough to accept any IP address that is given to it. So next, we have specify protocol family IP address, now the port number, which is also very important. So we say server address dot syn underscore port, and then first port. Now we are going to make a variant of that particular function. With this one, this time around, it is short. It's used host. It will convert from host byte order, network byte order, or to network byte order, any integer that is of short data type. And then I'm going to say, now since we remember that we given the user that is going to specify the port number while running the program, so we want to make use of this particular array index to access that particular port number that the user is given to our application at runtime. So I'm going to say argv 0. Is it 0? 1, because 0 is the name of the this particular file that the user is going to enter. Remember here I gave an example here. This is the first index. This is the first element, index 0. This is second element, index 1. Okay, so we are referring to it of index 1, which means the port number that the user is going to issue over the terminal at runtime while running this particular program. But the issue is that if the user pass it, is going to be, remember this is a way of representing strings as a character array. So it's going to be in the form string. So we need to convert it from string to integer, since our program expects a port number to be of integer data type. Remember, this is host network byte order, and it is expecting a short integer data type. So we make use of a function called a toy. Now this is responsible for converting from string to integer. So this will make sure that our string has been converted to integer. Okay, so we have fill our server address dot all our server address structure. Now we can now bind this server address to our socket. So to do so, we are going to invoke a function called bind. So but I'm going to use it this way. I'm going to say bind status, and I'm going to initialize a comment int bind bind status, and I'm going to say bind. I'm going to invoke the function, and I'm going to pass to it server address. Yes, then followed by struct sock addr in sock addr, and then followed by size of server address. Okay, so what I just did is that this particular bind is a function that we can use to bind the socket, to bind our socket. Since we have already filled this particular structure server address to contain the protocol family, the IP address, and the port number, now we need to bind it to our socket so that our socket will be associated with those parameters: the protocol family, IP version 4, the IP address that is given to this computer, the port number. Now we need to bind it to the socket. So sorry, here this is not a server address that's supposed to be here. It is socket, please. Socket fd, server socket fd. So our socket, we pass the socket as an argument to this particular function, and then followed by the address. Okay, also here I've omitted something. On to server address. Okay, server address. So I'm telling that this server socket file descriptor should be bind with this particular server address, and then these are the argument required by this particular function bind. So it needs the socket, and then the address that is going to be bind to, and then the size of that particular server address. That is why we make use of this particular function, size of. Now this particular struct sock addr is required here, because ordinarily we could have make use of sock addr to create our server address, but instead we make use of sock addr in, because sock addr in is more friendly to use than sock addr. But eventually, before we make use of server address structure, we need to cast this particular struct sock addr to our server address. and then we are just telling the computer the server address is of this type of structure, sock ADDR. Then that is just a convention, a way of doing this particular socket programming. So whenever you want to do so, you make use of this. You create your structure of server address in, and then later you cast this particular sock ADDR into that instance of that particular structure that you created. All right. Yeah. So next, we have performed binding. Now, but we need to check. We should always perform check to make sure that the bind has been successful. That is why I'm even creating these variables and initializing them to the particular functions. So I need to check now. I'm going to make use of my bind status. I can say if bind status is -1. If it is -1, it will issue -1. This bind will return 0 if it is successful, and it will return -1 if the binding has not been successful. So now we need to handle that so that the user will not see the program hanging, the program refuses to perform up to expectation. It will show him that there's an error if there's any error. So it will just a way of error checking. To if there's any error, then notify us of that particular error at any particular time. So we need to I'm going to define a function, but let me just call the function here. Let me define a function. I'll later define the function. I'll call it error handling. So error handling, and then I'm going to pass to it just an error, a message. I'm going to say bind error. And then okay, so this is the way it is. So now let me go off and define a function prototype so that my C program will know that there's a function that I'm going to later on define at the end of function main. So I'm going to function prototype. So let me make a comment here, function prototype. And then now I'm going to define my function. My function will not return anything. That is why I have it void as the return type. Now void is the return type. Now the name of the function is error handling. And then also it is going to require a message string to be passed to it. So I defined a pointer char message. So whenever we invoke it, we are going to pass to it a message which is of char data type and a pointer to this particular message. I will pass a pointer to a character data type as the parameter of this particular error handling function. Okay, so now we continue coding. Okay, also here after we create the socket, okay, wait for here. Let me just do something like this. And a bind status. So just copy this one here. Copy, and then just paste it here. So now let me just copy this, because after creating upon creation of the socket, we could have also performed this particular check. So whenever we invoke any function, let's check to make sure that the right thing has been done. So if server socket fd, if server socket fd equals to -1, then error handling socket error socket error. So it's going to tell us that there's an error and is of type socket error. All right, here we are. So we have created the socket, we have bind the socket. Now the next thing is to listing over using the socket. So now we're listing. So to listing, I'm also going to define a variable. I'll call it listing status. Status, and then I'm going to invoke function listing. And invoke function listing will require the socket, server socket fd, followed by a backlog. So here listing require two arguments: the server socket that we created, and then backlog. A backlog means the number of clients that will wait on a queue at a time to be attended to by the server. And here I specify 5. That means that after the first client is being attended to by this server, then 4 additional other clients should wait to be attended to by this particular server. So so that 5 of them are on the queue waiting to be attended to. So that is the essence of this backlog 5. And then we specify 5. You can say 6, you can say 7, it depends. So you can just specify any number of clients that could wait to be attended to by the server. All right. So and then now we need to also check if the listing has been successful. So I'm going to check if listing status. Now listing status equals to minus -1, then we'll say listing error or listing error, and then just copy this one here, and this is for listing, not buying. So let me just paste this one here, paste this one here, paste. All right, so listing, we have listing, we have created the socket, we are buying the socket, we are listening with the socket now. Since we are listening, that means that we can hear an incoming a socket, a client socket making a connection request. So if we hear, since we are listening, we are bound to hear a client socket making a connection request. So once we hear that, we should accept it. So for that, we need to create a function. We need to make use of function accept. So accept incoming client socket, incoming request for connection. Okay, so we are going to accept a client socket. So int client socket file descriptor. So if we have a request, we should accept it using our accept function. So accept function will accept the incoming socket. That is why we define a variable client socket fd. So we should accept it. And to accept it, we are going to make use of our own socket server fd, followed by just similar to what we did in bind. So struct sock addr, a pointer, address of server address, and size of server address. So now this will make sure that we accept the client socket fd that is coming using our function accept. So also we can check if the acceptance has been successful. Control Z. If the acceptance has been successful using our this particular function. If it has not been successful, issue out an error message and then exit the program. So if client socket fd, if client socket fd is -1, what do we say? We say what do we say? We say accept error. So we say accept error. So this message accept error is going to be printed out. So let me copy this one here. I'm going to copy copy. All right, copy it here, and I'm going to paste it here. I'm going to paste it. Let me paste it here. So it's going to accept it. So we have created the socket, we have bind the socket, we have listing, and we have accepted an incoming connection request. Now everything has been set. We need to communicate with our client. Communicate with the client. With the client. All right. So now we need to communicate with the client. So to communicate with the client, we need to send him a message. As I said in the earlier of this, in the beginning of this program, the essence of this program is to create a server that will simply send out a hello message to any client that connect to it. So for the purpose of that, I'm going to need to create an array char message, which is going to contain the particular value that we want to send. Hello world. You know, hello world is usually the beginning, usually the first program that we create in any new language. So this is server programming, new to us. So we want to create a hello world message. So char message, hello world. So we want to send this message. And to do so, we are going to write to the socket. As I've said earlier, a socket is just treated like a file. So we open it, just as we open a file, we write to a file. So likewise here, we need to write to particular socket that we created. So I'm going to say write what are we writing? We are writing to the client socket FD. And what are we writing? Message. And then followed by size of the message. So this particular function requires these 3 parameters. First of all, the socket descriptor, the socket file descriptor to write the message to, followed by the message and the size of message. So this will make sure that this thing has been written. So if there's any error, it's also return -1. Control Z. Also return -1. So we can check for that. We can check for that. Then so let me here write status. That's the right. So I'll just come up here and then check to make sure that something has been written to the client socket FD. So if write status is -1, if write status is -1, error handling accept no write error. So we can write write error, and then the program will exit, so that we can come over and rectify whatsoever the issue is. So now after we have communicated with the socket, our goal is to just send this particular hello world, and we have done so. We have achieved our task. So all that we need to do now, we need to close the client socket first, FD, then we close the and then next we close the server socket FD. Then our program has finished and we can return 0. So we have successfully implemented our server program. Now remain the error handling function that whose function prototype we defined. So error handling. So our error handling function. So I'm going to define it as void error handling, and it's going to require char, a pointer to a message, and then we need a foot function, and we are going to pass the message to standard error string, and then pfoot c attach the null terminating character. You know, after printing out a string which is a character array in C, we need to specify that this is the end of that particular string by inserting a null terminating character. So this is a null terminating character for a string /0. Okay, and then finally we exit 1, which means unsuccessful. The program has failed, or like return 0 or exit 0, where we means a successful exit. So the exit 1 means exit with failure. So as usual, end error handling. So I'll just copy this, and then I'm going to paste it here. So I'm going to save. So now next, let's go and compile our program. Even though there's not any server to communicate with, there's not any client to communicate with it. But if there is any error, we come over and fix the error. And if there's any error, then we round up the video. And the next video, we create our client program to communicate with this particular server. So I'll just come here and open my command line, my terminal, and navigate to where I have this particular file. So cd document, programming, YouTube, clear, and then we need to ls hello server to C. So good. So now I'm going to compile the GCC hello server to C. I want to output it as hello server only. Now we have errors. Warning: passing 3 argument of accept makes pointer pointer the cast socket accept server structure ADDR size of server address. What is the issue? Long unsigned int. Int client socket FD client socket FD struct sock addr and server address, size of server, long unsigned int, size of server address. Okay, passing argument 3 of accept makes pointer from integer without a cast, size of server address. So what is the issue? Okay, and then circlet restrict aq unassigned, error right status best using this function. All right, right status. Let me go and so the other ones they are arguing, they are something 76. Line number 76 is where we have an actual error. So line number 76, 76, 76, 76, 76, 76. Int, yeah. So int status accept the server socket, accept using our server socket fd using okay, yes, I've made an error here. It's not supposed to be server address, it's supposed to be client address. So we need to define the client address, because the client is going to connect to our socket, to our server using its own address, using the address of the server proper, but defined in its own program. So we need it to define server address, sock lengthy, server address, so we need to create another structure. Sorry, I'm very struct, server address, wow, yes, struct, I'm sorry, sock addr, and I'm going to say client address, client address, just as we had it in server address. Okay, and then I need also another sock lengthy, size of, and then I'm going to first size of, no, yes, size of client address size. So client address size, I'm sorry, I could have done this since, and then sock lengthy, client address size, and then client address size of client address. All right, sock lengthy, client address size. Okay, and then I can even do it in this particular line. I can define and initialize it, and then I'm going to say size of client address, yes. So I need to do this before coming to accept this particular. So I'm accepting the connection, I'm accepting client socket file descriptor using the server socket file descriptor, and the client socket via the client socket, via the client address, rather, client address. And also here I'm going to pass it by address. I'm going to pass not just size of address, the and size address of this particular size of client address, so which we have already defined here. So we say sock lengthy, this is a type of defining a client address size. So we say client address size, this particular variable is of type sock lengthy, and we say size of client address, and then here we just say address of, using this particular C address of operator, address of client address size, This is the way we're supposed to do it. So control End. Let me make sure I put a statement terminator. Okay, I have extra. Do I have extra parentheses? 1, 2, 1, 2, 3. Okay, I have extra redundant. So let me do away with it. Save. Okay, so hopefully we won't have any error here. So I hope this is clear. So we need to create another structure for the client address. So the client address is going to define the address in his own program. You just connect to us. But for us to accept it, we need it to define it of type sock addr in, not addr, just as we define it for the server address. So sock addr in client address, and then the client address size of type sock lengthy, and then we initialize it with the size of client address, this client address structure that we created here, and then we pass it address of, by reference, address of client address size. Also here we cast sock addr to client address. Okay, so this will resolve the issue, hopefully. And then let me go to the terminal again and attempt to recompile the program and then see. So see, so as we can see, we don't have any error, and we can run our program. Hello server, and then let me run without any fault. So as you can see, to run the server, we have to issue the name of the server followed by a fault. So let me give the fault, let's say 56667, and then run. So as we can see, our server is running, waiting for a client to communicate to it so that it will send the message hello world to it. So I'm going to terminate it, Ctrl C, and then I'm going to clear the screen. So thank you for watching this video tutorial. In the next tutorial, we are going to create the client program that is going to communicate with this particular server program. Thank you.